Hello and welcome to another CS0 Intro to Java Programming video. In this video I'm going to build off the previous video that was about nested inner classes. I'm going to use the same structure, I'm going to do all the same things, but I'm also going to add something called if and else, our first control statements of this course. If you did not watch the video that was on nested inner classes, you need to stop this video right now and go back and watch it, because there's a lot in this video that'll just fly over your head if you have not watched it and did not fully understand what was going on in that last video. So let's get to it. I've got this class called Ifelse Basics. So public class Ifelse Basics extends JFrame, implements action performed, or action listener. And it is going to be a JFrame that will have a couple buttons that when I press those buttons, things will happen. A button that says change color, change the color of the oval. Bigger makes it bigger, smaller makes it smaller. This is nothing that we haven't done before. We've done this in many lessons since we got action listener. But we're doing it a little bit differently. In the last video, you saw that we made a nested inner class, and that allowed us to access the graphics context of a custom JPanel and control where that graphics context was going to be in the frame, and allows us to explicitly repaint or call the repaint method of the paint component from that JPanel, thereby redrawing the whole graphics context and not leaving the old drawing on it. It wipes the graphics context clean and then redraws it completely. Let's look at the code. All right, we've got our class header that we already saw. We've got our instance variables here that are up at the top of the class as always. Oops, there we go. I've got a couple of constants, so private final int display width, final int display height. And this is very similar to the previous video, and I explained that constants are great because they never change, and they're great because we use them in place of hard-coded numbers, and when we change the constant up here, it'll change it for every place you put it in the entire class. Now I've got something going on in this one where everything is going to be dependent upon the width of the frame. So I set the display width to 400, and then I set the height to the display width. So if I change display width, the height will change as well. That'll make these always be square. So if I make this 800, it'll also change the height to 800, and you'll see that my frame will be bigger. See, it's much bigger. You'll also notice the oval is bigger as well. If I make this smaller, go down to 200, the frame will be smaller, and the oval will be smaller as well. I'm doing everything relative to one another here, okay? And it's all dependent upon this display width variable. So let's look at how this kind of cascades downward. All right, so display width is 200, display height is set by display width, and circle size is defaulted to display width divided by 2. So as soon as I draw it, the size of the circle is going to be half the size of the display. When I go down to my drawing, you're going to see that the oval, the g.fill oval, is set to display width divided by 2, circle size divided by 2. So this is setting up the oval directly on center of that graphics context. So we're dividing that graphics context in half, and that'll give us the center point. Then we're subtracting circle size divided by 2. That's going to put the center of the circle on the center of the panel. We've been doing this type of thing for quite a while now. This is nothing new. Okay, we saw this when we started introducing drawing and drawing relative to things. So I'm doing the same thing with the height, and I'm setting the circle size by circle size and circle size. It's going to be the same height and width. Okay, so the circle size is going to be half the size of the display. Great, so that's how I'm using these constants. Now the cool thing is, if I change just one value in this whole program, the whole thing is going to change. If I set this back to 400, the size of the display gets bigger by 400, the oval is going to be drawn at 200 by 200, and it's going to then center itself on that 400 by 400 panel. Really pretty cool. Now let's say I didn't use these constants. Let's say I just set the default size of my panel at 400 and 400 here. I hard-coded 400 and 400. And then down here, I set this to 400 divided by 2, 400 divided by 2, 200 divided by 2, 200 divided by 2, and 200, 200. I hard-coded all those values in. It would look something like this: 400, 400, 200. It's already a pain just changing all these values. 200, 200, 200. Okay, so that I've got all of those set to hard-coded values. Now if I make the display size bigger and smaller, the oval doesn't get bigger and smaller along with it. Those values are hard-coded. Furthermore, when I read this fill oval statement, I have no idea what the 400 and 200 are referring to. They're just numbers. They don't have any kind of semantic value. They have no meaning to them. They tell me nothing about the state of the program or the choices that I made. There's no explanation as to why I set those to 400 and 200 respectively. That makes your code hard to read, and it makes the intention of the code as the software developer intended it hard to understand. But if we use constants in place of hard-coded numbers and we use variables in place of hard-coded numbers, the intention becomes clear. You can look at this here and read through that code and go, oh yeah, that software developer was intending to make the oval be circle size and show up on center on the application. So it makes the program clearer and easier to read, and also makes it so that if I just change one value, that value cascades down and changes things for the whole program. That's the power of doing things in relation to one another, and that's the power of using constants. From here on out, I want you to get in the habit of using constants in place of those hard-coded numbers. Those hard-coded numbers, like this, 400 and 400, are called magic numbers. And magic numbers are to be avoided in your programming. A magic number is defined as a number that has no semantic meaning or value. It's just a number that's put in there and doesn't describe anything except for a number. It doesn't describe the purpose of that number or why it was chosen. You want to avoid using magic numbers for all the reasons that I just described. All right, so back to the code. So those are my setting up the state of my program there. I've got a GUI panel. I've got my display panel like you saw in a previous video. It's that nested inner class called display panel. It extends JPanel. It has its own graphics context and its own paint component method. I've got 3 buttons that are created and a color. So you're going to see that this is almost identical to the previous video. In fact, all I did is I copied and pasted the code and then added onto it to make it a little bit more updated. Right? So I'm instantiating my frame object. I am setting default close operation, setting my layout to border like we saw in the previous 2 videos, and I'm setting up my GUI. Then I'm packing as I showed you in the previous video and setting visible to true. Setup GUI is just going to get our content pane, instantiate our display panel. We'll look at that class in just a little bit. Instantiate our JPanel with a flow layout and into GUI panel. Creating my J button for color, change color, adding an action listener. Creating my button for bigger, adding an action listener. Creating my button for smaller, adding an action listener. And then adding those buttons to the GUI panel. Adding that GUI panel to the border layout south. And then adding display to the border layout center. So when I run this, you'll be able to see that the GUI panel that holds the GUI is going to be in the south. And the drawing panel is right here in the center. So this is the center of my frame, the border layout center. This is border layout south, which contains the panel with my 3 buttons. Okay? That's how this is set up. Now, let's take a look at the reason why we came to this video. We wanted to talk about if-else statements. If-else is the first set of control statements that we're going to get into. What they do is they allow us to change the direction that our code is going to take, or that the computer is going to process through the code. It sets up essentially like roadblocks that diverts traffic or allows traffic through. So let's look at it. in my action performed, I have an if, else if, and then a repaint. And what I'm doing here is in these ifs and elses, I'm updating the state of my variables. I'm updating the color or I'm updating the circle size. So to understand how these if-elses work, we have to understand the way action performed works. So action performed, we know that it is implicitly, or not by us, it's implicitly invoked when an action event happens. So when I click on a button that has a listener applied to it, action performed automatically invokes. All right, so this this right here, smaller, bigger, and change color, all have action listeners added to them. So when that action listener interacts with a component, it fires off something called an action event. And an action event is then consumed or taken in by the parameter argument action event here in action performed. So when action performed invokes, that action event will come off that button. So if I click the smaller button, an action event will come off the smaller button. It won't come off the other buttons, only the smaller button. If I click on the bigger button will fire off the action event and it will come into action performed. Now what we can do is we can inspect that action event and see what the source was. In other words, we can see what button fired off that action event or gave us the action event. And we do that through e.getSource, e being the variable of type action event in the parameter. So that parameter is going to hold the action event that comes into action performed. And we can use it, we can access it by accessing e. Well, action event has a method called getSource. So when I call e.getSource, it's going to call the getSource method to whatever action event came into this action performed method. So if smaller comes in, sends the action event into action performed, E is going to represent the action event from the smaller button. And when we do get source, it would be, smaller would be the button that would be the source. So what we're going to do is we're going to check that source against one of those buttons. In this case, change color. So let's look at what if and else if are. If is a reserved word. In other words, it's a word that can't be used in any other way except for this context. And if is always followed by this conditional statement here. It's those parentheses. And whatever is in those parentheses has to be a Boolean value. Let's think back to our primitive types. Int, double, short, long. There's one primitive type that I introduced but I didn't talk about in great depth, and it is the Boolean type. The Boolean type is 1 bit. In other words, it can hold one of two different states, either on or off, or true or false, if you will. It can hold the literal values true and false. Well, the if conditional statement here is looking for some sort of Boolean value. It's looking for a true or a false. And we can make statements in these if conditional statements that will resolve to true or false. For example, e.getSource equals change color. This is our equivalence operator. It is the equals operator. You might recall that anytime I have an assignment statement like this with this operator, I would always say display gets, and that's the gets right there, new display panel, or GUI panel gets new J panel. I never say GUI panel equals new panel because this is not equals. And that just kind of confuses people. It would confuse me if I call this the equals. Get out of the habit of saying equals for that operator. That's the assignment operator, or what I would say gets, or is assigned to value. This is the equals operator. The equals operator, or equivalence operator, has two equals symbols. And what it does, it compares something on the left side of it and the right side of it. The equals operator takes two operands. And what it's going to do is see if both of those operands hold an equivalent value. So what it's going to do is it's going to look at what is returned by this source method and then look into this variable and see if they are the same reference. In other words, to see if they have the same identity or if they are the same object reference. All right? And if they are, it will return true. If this statement resolves to true, Java will let me pass this if and get into these braces and execute everything in between these two braces that are associated with this if. So like I said, it's kind of like a gatekeeper. This statement right here, this Boolean conditional statement here, is my gatekeeper, and it says whether or not we are going to have access to the statements below it. If this resolves to false, so let's say I press the smaller button, it's going to go get source, which is smaller, equals change color, and it's going to find those both have a different reference, and it's going to return false. It won't let us into this statement here, and it's just going to move on. Okay, that's what if does. It allows us to make something happen or move on. And if an else, or if an if sees an else below it, it'll automatically execute this thing. Okay? If the if is not true, it will go on to this. Now, with an else, we can also nest another if in it. So this is saying if this is true, we're going to check this. And if this condition is true, we'll do this. If this condition is not true, we will then move on to the next step. Oh, here's another if. So if this one was not true, else will be executed if this is true. If this is true, we'll execute this. If it's not true, then we just move on. If none of these things are true, we don't get to execute any of these statements that are associated with those ifs. And we just do everything that comes after it. It'll just skip over all of them and move on to everything else in the program. All right? That's how if-else works. It'll allow something to happen or choose not to let something happen. Now, if the if evaluates a true, let's say that this if evaluates a true, we're going to execute this statement, and we're skipping over all of the else's that are attached to it. So it'll skip this, and it'll just move on. This is called an exclusive choice. What I mean by exclusive choice is one of these things can happen, the other two cannot. So if this resolves to false, but this resolves to true, we will skip over this, we will execute this, we will skip over this, and we will move on. If the third one, get source smaller resolves to true, it'll skip over this because it's false, it'll skip over this because it's false, it'll execute this, and then it'll move on. It'll only do one of them, okay? That's what an if-else chain does. It allows us for an exclusive choice. We'll get deeper into this in the next unit when we talk much more in depth about control statements. All right, so once one of these choices are made, we're going to force a repaint, display.repaint. So remember, display is my object from the display panel class, and I am going to invoke the paint component method. So let's look at paint component in our display panel. So display panel extends JPanel just like the previous video. If you did not watch the previous video, you're probably lost by now. So go back and watch that if you didn't. But if you did, this is where we are. And then we've got our constructor. Constructor, as I said before, sets up the initial conditions of an object of this class. So as soon as I instantiate a display panel, when I do display panel, display gets new display panel, this code executes. So we set the preferred size, and I'm setting it to display width by display height. I'm setting the background color to white. All right, so invoking repaint. Repaint is going to explicitly call the paint component. So what's going to happen in here is we'll call to super, we will set the color, and then we'll fill an oval. And we already saw what this fill oval looked like. It's going to be on center, and it's going to be the circle size. Now, what it does is, in our action performed, it updates the state. We're going to make a random color and assign it into C, or we're going to set the circle size bigger or set the circle size smaller. It's going to do one of those three things. And then we come back and force a repaint, and based on that new state, let's say it changed the color to a new random color, that new color is going to be in C, and when we press that button, that color is going to update on the circle. If we made the circle bigger, you'll see that the circle size will have gotten larger, and it's going to offset where that circle draws based on that circle size. Okay? So we're using that if-else to update one of those values of the state, and then when we force a repaint, it's going to repaint based on that new state. All right, so that's the basics of if and else. In the next video, I'm going to talk about using Boolean flags along with if and else to help update the state. Thanks for watching.